Hello and welcome to our today's question on transportation and optimization of a transportation problem. So, as we know, the transportation problem is done in two steps. First is you need to find out IBFS. Second is you need to optimize upon your solution. Whatever solution you have found out in IBFS, you need to optimize upon it. For IBFS, we have seen that there are certain techniques, like there was northwest corner method, then there was least cost method, and then there was Vogel's approximation method. Now this is a very basic technique. LCM was an advancement over northwest corner method, and we saw that WAM is best technique. So for IBFS, we should, unless mentioned, always use WAM. Similarly, for optimization also we have two main techniques. One is stepping stone and another one is modified distribution, or it is also known as UV method. So for optimization, if nothing is mentioned, we should always go with this technique, modified distribution or UV technique. So I assume that we know how IBFS is made. Today we'll take a question in which we'll be solving the IBFS using WAM, and then we'll go ahead and optimize it using modified distribution. Now let us write down our question. It is a small question wherein we have our sources A, B and C, and then there are destinations. Let us call the destinations as P, Q, R and S. The supplies available at sources are 6, 1 and 10, while the requirements of the destinations are 7, 5, 3 and 2. So that makes 7 and 5 12, 12 and 5 17, and we have 17. So we have supply of 17 and demand of 17. So it is a balanced problem. As far as the transportation costs per unit are concerned, it is 2, 3, 11 and 7, 1, 0, 6 and 1, 5, 8, 15 and 5, 8, 15 and 9. So these are my transportation costs per unit. If I transport one unit from C to R, it costs me 15 rupees. If I transport one unit from B to S, it costs me 1 rupee. So these are the per unit transportation costs. Now we need to go ahead and make initial assignments. We need to find out IBFS. What is IBFS? Initial Basic Feasible Solution, IBFS. Now, because we are solving this question using WAM, so first let us find out penalties. For first row, the penalty would be a difference of 2 and 3, giving me 1, 1 and 0 giving me 1, 5 and 8 giving me 3, 1 and 2 giving me a 1. These are my penalties. So my penalties for first stage are 1, 1, 3, 1, 3, 5, 6. This is the highest penalty. We need to stop this penalty. So in order to stop this penalty, I go to S and ask it to go ahead and avoid this penalty. If S makes an attempt to avoid this penalty, it will rush into the least cost cell, which is 1. It will not go to 7 and 9, rather S will rush to this 1 rupee cell in order to avoid this 6 rupee penalty. For this 1 rupee cell, it will be a deal between B and S. Now B has 1 unit to supply, S needs 2 units. So how much will be the deal? B can supply only 1, S needs 2. If S needs 2, still B can only supply 1. So there will be a deal of only 1 unit. They'll make a deal of 1 unit and that's it. Now what happens when they make a deal of 1 unit? S needed 2 units, it has 1 unit, but still it needs 1 unit. So we are updating the load of S. And as far as B is concerned, B is exhausted and hence removed. Now let us go ahead and find out penalties of second stage. 2 and 3 would still be a 1. This is done for now. 5 and 8 would be a 3. These will be updated. Here 11 and 15, 7 and 9, 2. These are our new penalties. 1, 3, 3, 5, 4, 2. The largest penalty is 5. So this penalty will be on Q. So we give Q a chance to avoid this penalty. If we give Q a chance, it can run into the 3 rupee or 8 rupee cell. It will run into the 3 rupee cell because it is the cheapest one. For this 3 rupee cell, it is a transaction between A and Q. A has a supply of 6, Q has a requirement of 5. So what will be the deal that they'll strike? They'll strike a deal of 5. When they strike a deal of 5, A had a supply of 6, it has supplied 5 units, it can still supply 1 unit. 1 unit. Fine. Now, as a result of this deal, source Q is now exhausted. It needed 5, it has 5. Let us find out next level penalties. Now we have 2 and 7, penalty has gone up to 5. We have a 5 and 9, penalty has gone up to 4. 2 and 5, these penalties are still the same, this is done. 4 and 2. So now the penalties are 3, 4, 2, 5 and 4. This is the highest penalty. And A will be facing this penalty, so we give A a chance to avoid this penalty. When we give A a chance to avoid this penalty, it can run into 2 rupees, 7 rupees or 11 rupees, any of these cells. Where will A run? A will run into the 2 rupee cell. In 2 rupee cell, it will be a deal between AP. A has 1 unit left to supply, P needs 7 units. So their deal will be of only 1 unit. A is exhausted and P needs to be updated. Whenever an assignment is made, you need to update the row and column. How am I updating the row and column? I am updating the demand or supply and I am removing. So these are the updates. And now we see we are left with only one column. One row. So we know that when we are left with one row or one column, at that time the demand and supply are matched. Let us see. C has a supply of 10. What are the demands? 6, 3 and 1. 6 and 3, 9 and 1, 10. So I can go ahead and directly assign these, allot these. You can get 6 from here, you can get 3 from here, and you can get your 1 unit from here. This is it. So this is my IBFS. What is my total cost for this IBFS? It will be so the total cost at my first stage is 102. 2 multiplied by 1, 3 multiplied by 5, 1 multiplied by 1, 5 multiplied by 6, 15 multiplied by 3, 9 multiplied by 1, and so I get a total cost of 102 rupees. Now this was my first stage. Now I'm through with my IBFS. Okay, I used WAM for this IBFS and now I'm through with it. Now when we go in for optimization, there will be a lot more tables. If it were only an IBFS, this is my solution and we are done with it. But when we go for optimization, there will be a lot more tables. So I need to give them some meaningful names. So let me give this table a name, table 1.A. This 1 is indicating that it is first stage, A is indicating that it is first table of first stage, A table of first stage. Before we could actually advance on to the optimization phase, we need to check this problem for degeneracy. If the solution at this stage, at first stage, that is this solution, if this solution is degenerate, then we cannot advance further. So the condition for advancing further is a small one, m plus n minus 1 should be equal to number of assignments. What is this M? It is number of rows plus number of columns should be equal to number of assignments. We had 3 rows, 1, 2, 3. Then we had 1, 2, 3, 4 columns. So it is 3 plus 4 minus 1 should be equal to number of assignments. How many do we have? 1, 2, 3, 4, 5 and 6. So I have 6 assignments. 3 plus 4, 7, 7 minus 1, 6. If this is equal, then I can definitely advance to my optimization. And for optimization, we have our table 1.A. Let us make another table 1.B. Here we have our table 1.P. Let me call it table 1.P. What is this 1.B? First phase and table B. Now there are certain steps for moving further. Now because it is a long process, we'll try to write down those steps. First step is so here are the steps. First step, let me select red pen for first step. Transfer the costs of assigned cells. Now if we have a look at this matrix, the assigned cells are, we'll use some color. All these are assigned cells. So I will transfer the costs given in these cells. What is the cost of this cell? 2 rupees, 3 rupees, 1 rupee, 5 rupees, 15 rupees and 9 rupees. So I have done my first step. Second step is find values of U's and V's such that Ui plus Vj is equal to Aij. Now it looks complicated when we say U and V and In, but it is very simple thing. These will be U values and these will be V values. What are these U values? U1, U2, U3, V1, V2, V3, V4, and these are A values. A11, A12, A13, A14 and so on. Fine. So we need to find out U and V values such that Ui plus Vj is equal to Aij. Now it is very simple concept. You need to find out these U and V values such that when this U, when this V and U travel in, it should give me the sum. That is U3 plus V3 should be equal to 15. Fine. And if we go here, U1 plus V2 should be 3. Okay. So can we try this? U3 plus V1 should be 5. Now yes, definitely we can find these values, but the problem right now is that where to start. If I have a look at this place, I have no idea what this value is, I have no idea what this value is, so I cannot start at this point. So find values of U's and V's such that Ui plus Vj is equal to Aij. We start this step by putting any of the U or the V's as 0. You can put a 0 over here, you can put a 0 over here, wherever you wish like, you can put 1 0 to start this puzzle. Now, where do I put? You could put anywhere. You have 7 options, V1, 2, 3, 4, U1, 2, 3. You could put that 0 at any place. But preferably, I will be putting this 0 in a place where there are maximum assignments. For example, U1 has 2 assignments. U2 has 1 assignment. U3 has 3 assignments. V1 has 2, 1, 1 and 2. So this is the place where we have 3 assignments. So I will go ahead and put a 0 over here. Now, what was the rule? The rule was that at intersection, I should get 9. So what should I put here? I think a 9 should do the trick. If I put a 9 here, this 9 will come here, this 0 will come here, and their sum will again become a 9. By same logic, 15 plus 0. This 15 is coming from these two. Fine. What happens to this 5? Can we do this? Definitely we can do this. 5. So 0 and 5. 0 plus 5 is 5. So we started with 0, but now we have additional 3 values. And now with this trick, we can proceed further. What should I put over here? So that when this value comes in, I get a 2. What should I put? If I put a 3, this 5 and 3 would make an 8. So 3 is not a good idea. What should I put? Can I put a minus 3 over here? 5 and minus 3. They both will combine to give me a 2. Yes, definitely minus 3 is the way to go. Now here we can write a formula if we wish, like the formula to find these all values would be internal minus external. 2 minus 5. Internal value is 2. External value is 5. 2 minus 5 is minus 3. Now let me jump to this 3. For this 3, what I do? I have a minus 3. What should I put here? Not sure? No issues. We have our formula of internal minus external. Internal value is 3 minus external value is minus 3, giving me a 3 plus 3, making it a 6. So I should put a 6 over here. So 6 and minus 3 would make it a minus 3. So definitely now I know how I can find out all these values. Let us just clean this up. 6 minus 3 will give me a 3. And what about this value? Can I make use of these two cells, these two u and v's? 9, 1, internal minus external, 1 minus 9. 1 minus 9 is minus 8. So I can put a minus 8 over here. Now you have all u1, v1, u1, u2, u3, v1, v2, v3 values. So we are through with find values of u's and v's such that ui plus vj is equal to aij. Third step is fill in the vacant cells using this same formula. So now, right now I was finding out UVs. Now I will be finding out AIJs. Let us go ahead and find AIJs using the same formula. What will these AIJs be? 15 and minus 3. 15 and minus 3 would give me a 12. So this is the way we will be going in for these AIJs. 15 minus 3, 12. Or let me put it slightly smaller. 9 minus 3. I'm not subtracting, I'm actually adding 9 plus minus 3. 5 minus 8 would make it a minus 3. 6 minus 8, 15 minus 8, 7. 6 plus 0. So I'm through with my third step. Fill in the vacant cells using ui plus vj is equal to aij. Third step is subtract values of step 3. These are the values of step 3. Subtract values of step 3 from original costs. These are my original costs. Subtract the values of step 3 from original costs to get cost saving potential of unassigned cells from original costs. We'll split this complete step into two. Subtract values from original costs to get cost saving potential of unassigned cells. So first let us go ahead and subtract them, then we'll see what is this indicating. Of step 3, these are the values of step 3. So I'll be subtracting them from original costs. Is that fine? 11 minus 12 minus 1, 7 minus 6, 1, 1 minus minus 3, 4, 0 minus minus 2, 2, 6 minus 7, minus 1, 8 minus 6 is 2. Is that fine? This will be 4, 1 minus new value. Fine. Similarly, this one will also be 0 minus minus 2, 0 minus minus 2, making it plus 2 only. Now, subtract values of step 3 from original costs to get cost saving potential of unassigned cells. Now, cost saving potential of unassigned cells, if you have a look closely, these are, oh, sorry, I used the eraser. These are unassigned cells. The subtractions that we have made are actually unassigned cells in the original matrix. What do I mean by unassigned cells? Unassigned cells mean that in IBFS, I did not find them attractive. So I have not put anything over here. But there is a chance that these cells might have a potential. I have not put anything over here. I have not put anything in these cells, but there is a chance that these cells might be better than the cells that I have selected. There is a chance that the unassigned cells might be better. This is why we are going in for optimization. We have an answer. We have an initial solution, but now we are trying to see if this is best or not. We are trying to optimize upon it. We'll see if it is best or not. If it is not best, then we'll go ahead for a best solution. So, this empty cell has a potential of minus 1. This minus 1 tells me there is a cost saving potential of minus 1, while this cell has a plus 1, telling me that it has a cost potential of plus 1. So, which one of these two is better? Because we are talking of cost, a cost of minus 1 is better. What do I mean by a cost of minus 1? This total cost of 102. If you use this cell, it will come down to 101. If you use this cell, it will go up to 103. So this is what we mean by potential. If you try and make any assignment in this cell, your cost will go up by 4 rupees. Your 102 rupees will become 106 rupees. So what is this cost saving potential? How to interpret it? That these cells will take up your cost by 4 rupees, 2 rupees, 2 rupees and 1 rupees on the higher side, while these two cells will actually bring your cost down by 1 rupee each. Now, because I have two options, you have an auto which is saying that it can reduce your cost by 1 rupee. So which auto would you like? I would like an auto which could save me more. Now this is saying that it can bring the cost down by 1 rupee. This is saying that it can bring the cost by 1 rupee per unit. But which auto would I prefer? Who would transport more of my units? Who can take away more of my units in one turn? If this auto is saving 1 rupee per unit, this is saving 1 per unit, but this can take 3 units, while this can take 5 units. So which one is better? Definitely 5 units is better, because then I'll be saving 5 rupees. So this is what I need to check now in the next phase. So in any case, what are my cost saving cells? These two have been identified as very good cost effective cells, while others are in fact increasing the cost. So I will not be going with them. I'll be going with these two cells. Now let us proceed further and see how I can bring down the cost. Fine. So let us go ahead. and improve upon the cost. Now we see that we'll be needing this assignment and I'll be doing some rough work in this. So what I'll do is I'll pull this assignment outside so that we will not be damaging the real one. Also, I need a zoomed in thing. Okay, we'll remove it afterwards. Here we have. So this is our original assignment. I've just brought this here. You need not do this. I've just brought this over here. Now I have my two tables, table 1A and table 1B. What is this 1A? This 1A is first phase table A, first phase table B. Now I'm considering two cells which look like being reducing the cost. This cell can reduce my cost by 1 rupee. This cell can reduce my cost by 1 rupee. How do I approach them? In order to approach them, what I need to do is, one second, this is the cell. Which is this cell? This one. Fine. If there is some confusion, let me put in. We had A, B, C, and then these were PQRS. P, Q, R, S. Now this cell is AR. So this cell is AR. Now one thing is for sure. I definitely want to add something to this cell AR. I want to add something to this cell AR. What do I mean by adding something? Because there is no assignment in this cell, I wish to make some assignment. I wish to add some units over there. Now in order to be able to do that, I need to find out a closed loop. What do I mean by closed loop? Let us check it out. We have this a table of 4 by 3, a smaller version of this 4 by 3. What are the cells that are engaged? This cell is engaged. This cell is engaged. Then this one is also engaged. Then this is engaged. Then this is engaged. And lastly, so these are the cells that are engaged. Fine. And now I wish to engage this cell also. What do you mean by engage? That some kind of assignment is done. These are the assigned cells. Now I wish to make some assignment in this cell also. Now the rule is, the trick is, you need to find a closed loop making horizontal and vertical moves. Alternate horizontal and vertical. It could be horizontal vertical, it could be vertical horizontal, but they should be alternate. You are not allowed to make two horizontal moves, you are not allowed to make two vertical moves. One horizontal and one vertical, or one vertical and one horizontal. This is how you will have to proceed further. Now, how do you go ahead? In this case, closed loop. You can only put your steps on these cells. You can only put your steps on these cells. Now, look very carefully, very closely. If I start my journey from here and I proceed to this point, what is this? This is a horizontal move. Remember, I am not doing this movement. I am not going like this and then this. I am not making two movements, rather I am making direct jump. If I make this direct jump from here to here, this is a horizontal move. Now from horizontal I need to move vertically. From vertical I need to make a horizontal move, and from horizontal I can come back to my place. What we are doing is, we are starting our journey from a potential cell and then traversing a closed loop and coming back home. Fine? So this is what we need to do. And wherever we are stopping, we will be changing the signs. I started my journey with a plus sign. Where am I stopping? I am stopping at this point. I am jumping here, so I'll put a minus sign over here. Horizontal move. From this horizontal, I am making a vertical move. I'll put a plus sign. From this vertical, I am making a horizontal, vertical, horizontal, and last one would be your last vertical move. So if you make these moves, what I am doing? Horizontal, vertical, horizontal, and finally vertical, and I am putting alternate plus, and minus signs. If you are able to make these moves, then we'll see that we will be improving upon our total cost. What does this plus and minus indicate? That I wish to add some units over here. What does a minus indicate? I wish to subtract some units from here. Add some units, subtract some units. What is this doing? Now if you add something over here, 5 plus 1 is already 6. If I add something, this 6 will go up. If I add something over here, 3 is already here. If you add something, this 3 will go up. So what I am trying to do is, I am trying to balance it. I am adding something over here and subtracting. So this 3 is balanced. I am adding and subtracting, 6 is balanced. Now if I subtracted something from here, this 10 will be disbalanced. I'll add it. If I've added, subtracted. So in this loop, in this way, whatever I'm adding, whatever I'm subtracting, it all gets balanced. Fine. And what can I add and subtract? See, as far as adding something is concerned, no issues. Adding is, suppose you wish to give me 10 rupees. Give me 10 rupees. You wish to give me 100 rupees. Give me 100 rupees. You wish to give me 10,000 rupees. You give me 10,000 rupees and I'll keep them. As far as adding is concerned, it is not much of a problem. Problem is subtracting. You cannot take 10,000 rupees from me if I do not have. You can only take the amount of money I have. So adding is not at all an issue. Problem will be with subtracting. Can I subtract 10 units from this cell? When this cell is having only 1 unit, I cannot subtract 10 units. Can I subtract 6 units from this cell? No, it is not possible. Can I subtract 10 units from this cell? Not possible. Can I add 20 units here? Definitely possible. So as far as additions are concerned, no issue at all. What about subtractions? We need to look carefully. In subtractions, can I remove 1 unit from here? Let me check only these cells where I am reducing the load. Can I remove 1 unit from here? Yes, I can remove. Because there are 3 units, I can remove 1 unit. Can I remove 1 unit from here? Yes, I can remove. I have 1 unit, I will remove that 1 unit. Perfect. Can I remove 3 units from here? No. Removing of 3 units from here is just not possible. Can I remove 3 units from here? Yes. So I have checked 1 unit option in both. I have checked 3 unit option in both. 3 can be removed from here, but cannot be removed from this cell. Whereas 1 can be removed from here, can be removed from here, can be added here, can be added here. So the idea is, the thumb rule we can make is, we will be adding and subtracting the minimum of the assignments. What is the minimum of the assignments? It is 1. I'll be adding and subtracting this. Fine. So let us go ahead and make a new table, a table that will mark the start of our second phase. Now, what are the costs? It is 2311.7, 2311.7 from A, B, C, P, Q, R, S. These are destinations and these are sources. Then there is 1061, 1061. Then there is 5859, 5, 8, 15, 9. What are the loads? Loads are 7, 5, 3, 2, and then there is 6, 1 and 10. 6, 1 and 10. Now, these 4 cells I am about to change. So I will not be touching them. But the remaining ones can be copied directly. What are the remaining ones? 5, 1, 1. 5, 1, 1. As far as these 4 cells are concerned, they are engaged in a transfer now. What kind of transfer? I have decided that 1 unit will be transferred. 1 unit will be added here, making it 1. 1 unit will be subtracted from this, making it 2. Added here, making it 7. Subtracted from here. If you remove 1 unit from here, you are left with nothing. So, this is my new assignment. What I have done is, this 1 unit has gone here. As a result, 1 unit was subtracted from here. As a result, 1 unit was added here. So, some shuffling has taken place, and the result is that I have moved this 1 unit over here. This has become 2. This has become 7. 1, 2 and 7. Let me check the feasibility. 5 and 1 is 6. 1 unit is 1. 7 and 2, 9 and 1, 10. Done. All these are balanced. Then 7, 5, 3 and 2. Everything is balanced. Perfect. What about the total cost of second? I'll call it table second phase A. All A tables will be our original tables. All the first tables. This is my original table. This is my original table. This is my check table. This is my original table, and then I'll be having a check table. In any case, this is my assignment. What about the total cost? Total cost, you can find it out from here. 15 plus 11 plus 1 from here plus 35 plus 30 plus 9, making it a total cost of 26, 27, 32, 62, 92, 101. Your initial cost was 102. Now it is down to 101. We have made this transfer into this cell. But what about this cell? If you had taken this cell, what would have happened? That we need to check once again. Now we are checking if this cell had more potential. How do we check? Remember, we made a table, then we put up the assigned cells. All these were the assigned cells. Now this time you wish to explore this cell. This cell, which is BR. BR. This is BR. You need a closed loop. Do we see a very small closed loop? Yes, we have a closed loop. What does this closed loop mean? That where I start my journey, I'll be putting a plus. I'll make a vertical move and put minus. I'll make a horizontal move and make a plus. I'll make a vertical move and put minus, and I'll make a horizontal move and I'll be back. So this is my vertical, horizontal, vertical, horizontal. I started my journey from here and I'm back, making a plus minus move. Plus, minus, plus, minus. Now, how many units can be transferred? Leave the plus signs. How many units can be transferred? We decide from minus signs. The minimum in the minus values. Minimum assignment in the minus values is 1. So in previous case also I transferred 1 unit. In this case also I will be transferring 1 unit. So both the cases are equally good. None of them is dominating the other. So in this case, you can pick either of these, and I have picked the first cell. Now let me mark it as table 2. How we proceed? We have a table, original table, original assignment table, then we have a check table. We again have an original assignment table, then we'll have a check table. Let us make that check table. Now before moving ahead, we had to make a check of this condition. Can we at all proceed further? The m plus n minus 1, 3 plus 4 minus 1 is 6. Number of assignments are 1, 2, 3, 4, 5, 6. So here is our check table. What are the steps for check table? Transfer the costs of assigned cells 3, 11, 1, 5, 15 and 9. Then find out u and v values. Let us put this u as 0, so making it 5, 15 and 9. 1 minus 9 would be minus 8, 11 minus 15 would be minus 4, 3 minus 4 would be a 7. Then let us go ahead and find the values of these new cells. What will be the values? 5 and 4, making it a 1, 9 minus 4, 5, minus 3, minus 1, 7 and 7. Next step is subtract these new cell values from original costs. 2 minus 1, 1, 7 minus 5, 2, 1 minus 3, 4, 0 minus 1 is 1, 6 minus 7 is minus 1, 8 minus 7 is 1. So this time we have a cell which is saying that it can reduce the cost by 1 rupee for every unit that you transfer in here. This is my table 2b. This is my check table. Now after this check, I know that there is a saving potential here. So what I'll do is I'll put a plus over here, minus, plus and minus. This plus minus will give me my closed loop. Let me go ahead and make a new table to make these movements. How much movement is possible? We do not consider the plus cells, we consider the minus cells. From minus, the minimum assignment. We have an assignment of 1 unit, we have an assignment of 2 units. So we'll go ahead with an assignment of 2 units. Oh, sorry, 1 unit. The minimum of the minus marked cells. Let us go ahead. Now we have sources A, B, C, destinations P, Q, R and S, sources, destinations with loads of 6, 1 and 10, 7, 5, 3 and 2, and costs being 2, 3, 11 and 7, 1, 0, 6 and 1, 5, 8, 15 and 9. 5, 8, 59, 1, 0, 6, 1, 2, 3, 11, 7. Perfect. Now let us make this movement. Add 1 over here. If you add 1 over here, this becomes 1. Subtract 1 and add 1. This becomes 1 and this becomes 2. This becomes 1, this becomes 2. 1 removed from here, nothing left. The remaining assignments are 5, 1 and 7. 5, 1 and 7. Let us check for feasibility. 5 plus 1 is 6, 1 is okay, 7 and 3, 10 are done. Column wise 7, 5, 3 and 2. Done. What about the total cost? Third level. The previous total cost was 101. There was a cost saving potential of 1 and we have transferred 1 unit over here, right? So the new cost will be 100, or if you wish you could go the conventional way, you could just add up them. 15 plus 11 is 26, 26 plus 6, 32, 2 plus 18 is 50, plus 15 is 65, plus 35 is 100. So it again comes down to 100. So my third cost is 100. I started with 102 rupees, brought it down to 101, which has now come down to 100. So definitely I am optimizing on each step. Now let me check if this is best assignment or not. This is table third stage, A table. Let me make third stage B table. How do we go about this B table? Transfer the costs of assigned cells 3, 11, 6, 15, 9 and 5. This time let us take 0 over here. So this becomes 11, 6 and 15. 9 minus 15 would be a minus 6. 5 minus 15 would give me a minus 10. 3 minus 11 would give me a minus 8. Okay. And next step is find the costs of these, find the values of these empty cells. 11 and minus 10 would give me a 1, 5, 0, minus 2, minus 4 and 7. Let us go ahead and subtract these new found values from original costs. 2 minus 1 is 1, 7 minus 5 is 2, 1, 2, 1 minus 4 is 1 minus 4 is 5, 8 minus 7 is 1. So now all the cells are giving me positive potentials. Positive potentials is that they will add to the cost of 100. When there was a negative potential, it was actually bringing cost down. From 101, it saved 1 rupee for 1 unit. 1 rupee for 1 unit, bringing the cost down to 100. But this time, because I have everything is positive, so this is my optimum solution. This is the best solution. This is my optimum solution. And we can see this is my last table. Table 3B. So all our tables are in pairs. Original table of assignment, then a check table of B. In this check, we found that there was a saving potential of 1 rupee. We found a closed loop and transferred the units. So after the transfer, this was our assignment. We went ahead, checked it. After checking, we found another saving potential of 1 rupee. So we made a loop and we transferred that amount. After the transfer, I again checked it, and this time everything is positive, no negative values. So there is no potential for further improvement. So this is my final solution. This is your final solution. So this was modified distribution. If still there are any doubts or queries, you can leave them in comments section. We'll try to address them as soon as possible. Thanks for watching this video. Bye bye. Take care.